This is from 2018 AMC12 problem 7. We try to find the value of series product of logarithm with different bases. Now, we're going to review some of the fundamentals, but feel free to skip to the solution if you already know the content. Logarithm is the inverse operation of exponentiation. That is, if you have b raised to x power equal to n, then x would be the logarithm base b of n. So notice that the base is always a positive number. Now the logarithm of n to the base b is the exponent to which b must be raised to obtain n. So in mathematical language would be this identity here. It's very useful. That's by the definition of the logarithm. For example, we say to the third power equal to 8, but what's 2's power would give 7? The answer would be log base 2 of 7. Right? This quantity is slightly smaller than 3. Some example of logarithm, by definition, what is the value of here? You know that 2 raised to third power is 8, so that's equal to 3. How about that? 10 raised to what power? Second power, so that's 2. How about this? 5 raised to third power, that would be 3. Right? So notice that the value could be a negative or fractional value. It depends on the base and the number being evaluated. For example, in this case, 2 raised to what power produce 0.5? Negative 1. How about 10 raised to what power produce 0.01? That would be negative 2. And in this case, notice that 1 over 9 is 3 raised to negative 2's power. The answer is also negative 2. Okay? And other properties of this function, the log of the base equal to 1. And this by definition, earlier we know that. And here the logarithm of 1 equal to 0 because a to the 0's power is 1. It's also a useful property here. And some other property is that the product will become the sum of log. And the division will become the difference here, the minus here. And the power is going to be r times this. And another very useful fact is change of base. So this allows us to evaluate any logarithm with some known base. For example, if we have base 10 or base e natural log. Let's go back to our original problem from AMC. It's important to notice the pattern here with different base, odd number, and the base from 3, 5, 7 up to 23, and the actual logarithm value is from 7, 9, 11 up to 25 and 27. The trick here is to use change of base. Alright, what you can do is to change of base for each term and become fraction here. Notice that you're going to cancel a lot of terms. In essence, this is similar to a technique of telescoping when we deal with the sum of series. Now here's the product here, the fraction. Notice that on the top you start from 7, 9 up to 27, the bottom 7, 5, on the bottom 3, 5, 7, and then up to 23. Now you would cancel terms, like for example 7 would be cancelled, so it's 9, and so on and so forth until you get everything cancelled except for 3 and 5 on the bottom and 25, 27 on the top. So what you have here is this simplified fraction here. Now you're going to use another property, that is 5 is 5 squared, property that becomes 2 times log 5, and this is 3 to the cube, so this becomes 3 times log 3. We have this, and that will cancel, so this would be 3 and 2, that would be 6. So the answer to the original problem is choice C. Hope you liked the video. Please share and subscribe to the channel.